Morning. So hopefully we have another quick lesson for you today. Still working our quadratic equations. Just to get started, a little warm up. Just recall, what is the zero of a quadratic equation? When you hear about the zero, to what are we referring? And then C, we're going to do a lot of identifying x-intercepts and y-intercepts. So just see if you can name the two forms without being prompted. What is the two different forms of the equation we talked about last week? And then see if for your first graph, can you find the x-intercepts and the y-intercepts? Take a minute, pause the video, and see what of those you can do, and then we'll talk about the rest from there. So hopefully we remember that the zero of a quadratic equation, or the zero, is just the value of x that makes y equal to 0. It's also called the x-intercept, as we've been talking about before this unit, but for quadratic equations, we also just call them the zeros. So we also learned about last week how standard form of an equation was written just as a sum or difference. So x squared plus 4x plus 3 is standard form. Highest exponent first, lowest exponent last. Then factored form was written below. And that was when we had it written out like a big multiplication problem. So x plus 3 times x plus 1. And today we're really going to learn the purpose of writing something in factor form and how it can actually help us a lot when making graphs and stuff. And we can see that our x-intercepts from our graph hits the x-axis at -1 and at -3, or we could even write in the ordered pairs, -1, 0 and -3, 0. And for our graph, the y-intercept is also 3, or we could call it 0, 3. So our goal today, we're going to look and see the relationship between the x-intercepts and the y-intercepts and our equation. So start looking for where you see the x-intercepts and the y-intercepts in the equation, both in standard form and in factored form. One you might see somewhere, not somewhere else. One you might see in the other place and not in the other. All right, so we're looking at a bunch of these. Plenty of chances to pause, and then you can sort of build on your own hypothesis of where are my x and y intercepts in my equations. Okay, so next one. Let's look at blank form and blank form. What are the x-intercepts? What is the y-intercept? And again, build on your hypothesis. Can you get them from the equation, or is there a connection at all? All right, so for function g, or just our next graph, we have standard form and factored form again. And my x-intercepts from my graph are 1 and 4. So 1, 0, and 4, 0. And my y-intercept is also 4, so I see 0, 4. So really I want to look at my first graph and my second graph and see, all right, I have x-intercepts and I have y-intercepts. And I have two forms of an equation. Where do I see the x-intercepts in my equations? And where do I see my y-intercept in my equation? So I'm looking back and forth and see if I notice anything. And I think I noticed something. But I also have repeated numbers, so I want to make sure I'm really, really sure about this before I make any sort of good hypotheses. So I'm going to look at the next one real quick, and look at the following one after that. So again, where are the x-intercepts? Where are the y-intercepts? And then see if you can sort of build your hypothesis from there. So the x-intercept here are 3 and -3, and my y-intercept here is -9. So where do I see 3 and -3? Well, I see a +3 and a -3 here. Maybe those are related. And -9, well, I see my -9 here. Let's go back to my previous problems. Where's my y-intercept in my previous problems? That's -9 there, and that's -9 there. Is my y-intercept always in my equation? 4. Yes. And in the first one, my y-intercept of 3. Okay, that's also in my first equation. Cool. All right. So now let's look at my x-intercepts. My x-intercepts here are -1, -3. Are those in my equation? 3. That was the y-intercept, though. I have a +3 and a +1, so I'm close. Let's look down here. My x-intercepts here were a 1 and a 4, and in my equation I have, well, that was my y-intercept 4. I have a -4 and a -1, so it seems I have the opposites of my x-intercepts here. And then down here I have a 3 and a negative 3, and okay, I have a negative 3 and a 3. So yeah, the opposite of 3 is negative 3, opposite of negative 3 is 3. So apparently it seems that my x-intercepts are appearing in my factored form of my equation. Let's just go through the list and see if that is true. Alright, so down for function I, where is my x-intercept? Well, my x-intercepts are at 0 and 5. And let's see, I have a 5 here. I don't have a 0, I have this x. But couldn't I also write that x as, hold on, x minus 0? So I could write it like that too. And there's my 0 and my positive 5. Well, again, x-intercept is 5, but that seems, when I have a positive intercept, I remembered I subtracted, which seemed weird and counterintuitive, but there we have it. Because back up in here, we had a -4 and a -1, and my intercepts were a 1 and a 4. So we see our x-intercepts appearing in our equations, and my y-intercept here, again, was 0. And well, I don't see a 0 here, but I could also have written a plus 0 in my equation, right? It's kind of like in y equals mx plus b. If I had y equals 3x, that was a straight line that started out at 0, right? So let's go back and open Desmos calculator. All right, and I'll just say y equals 3x. And that had a y-intercept of 0 as well. It's just not written in my equation. I could write a plus 0 there to be the same exact line, but I didn't always write my plus 0. Same as if I write y equals x times x minus 5, I just looked at. I had that graph with the x and y-intercept at the origin. But that'd be the same equation if I wrote x minus 0. Right? That's the same as it was before. So really, I've created the same equation. So really, I see that my x-intercepts are having a big part in my factored form of my equation. And that's going to stay the same through there. And this one's kind of interesting down here, that I have an x-intercept of -2, and that's my only x-intercept. Alright, that's my only one, which is kind of weird, because that's where my vertex is as well. The vertex is actually the y-intercept. Alright, and that's my x-intercept. And my y-intercept is 4. Alright, still have a y-intercept, still normal there. So alright, my 4 is still in my equation, where it was before, with no x attached to it. But my factored form, notice, is the same expression, because it's x plus 2 squared. The factored form, and I only have one x-intercept, so it's x plus 2 and an x plus 2. And there's a special name for that. I don't know if we'll get to it later in the year or in Algebra 2, but there's a special name if there's only one x-intercept, and the root and the factored form looks like this. So you have x plus 2 squared, and there's our graph. So really our whole goal for today was to discover our noticings about the x-intercepts and the y-intercepts, and where they are in each function. So it's sort of giving you the observations. The x-intercept, or the zeros, appear in the factor form of the equation. However, they have the opposite sign in the equation. Sorry, my typing's awkward because I hurt my finger. Okay, so let's see. For example, if the is there a better example down here? Yeah, I'll just take this one actually. So if the factored form of an equation is y equals that. My zeros are 9 and 1. And let's see if we can figure out what our y-intercept is. Now, that's something interesting about the y-intercept as well that I never actually noticed until I looked at this lesson. So let's see, how are my zeros related to my y-intercept? So let's see, my x-intercepts were -1 and -3, and my y-intercept was 3. Okay, cool. Now here, my x-intercepts are 1 and 4, and my y-intercept is 4. Okay, so how are the 1 and the 4 related to the 4? I'm telling you, I just learned this today, so if you're just learning it now too, we're on the same page. So here my x-intercepts are 3 and -3, and my y-intercept is -9. Is there a connection between the x-intercepts and the y-intercept? Here my x-intercepts were 0 and 5, and my y-intercept was 0. Let me skip that one. Here my x-intercept was -2, and I'll write -2 again. Those are my two x-intercepts, -2, -2, and my y-intercept is 4. So what do you think my y-intercept here is going to be? If my zeros are 9 and 1, what do you think my y-intercept is going to be? I'll tell you the y-intercept is 9. So let's say where I got that from. So the relationship is that the y-intercept, I don't know why the time just appeared, is, spoiler alert, it's 9:45 p.m. The y-intercept is the product of the zeros. Or, so basically we multiply the x-intercepts together to get the y-intercept, which is pretty weird. And not necessarily essential, because we can just go to standard form and get it. Well, if you go back and look, you can see that, okay, -1 times -3 got me 3. Okay. 1 times 4 is 4. 3 times -3 is -9. 0 times 5 is 0. -2 times -2 is 4. And here, if I put this into standard form, by multiplying, we would get x squared, let's see, minus 9x minus x plus 9. So I'd get x squared minus 10x plus 9. So that is what my standard form would be. And the y-intercept is 9 because it's the product of the x-intercepts. Or you can convert to standard form and look at the number with no x term. So that's what we've been doing in the past. Like remember y equals mx plus b for slope-intercept form. That was my y-intercept there. And it had no x term. It had no x term attached to it. So it's pretty much a similar rule here. So yeah, the y-intercept is 9 for those two reasons. All right. So again, we're reviewing our vocab standard form, factored form, reviewing moving back and forth from factored form to standard form and just seeing where the x-intercepts are and how we can tell where they are in factored form. So remember, it's not the numbers you see exactly. If you see x minus 9 and x minus 1, my zeros aren't negative 9 and negative 1. They're positive 9 and positive 1. Let's just throw that on Desmos real quick so we can convince ourselves of this. All right, let's go back to notion of closed Desmos. It's always a terrible idea. Let's go back to Desmos. And I just copied and pasted my equation. And I see that my zeros are 1, 0, and 9, 0. And of course you can do Desmos for your exit slip. You will obviously have to do very similar things to this. And my y-intercept is 0, 9. Again, so it was 9 times 1. All right? And so if I thought my intercept, I'll change this real quick. And if my intercepts are positive 9 and negative 1, my graph would be blue. And it should be on the other side. And I see my x-intercepts of negative 9 and negative 1. Then my y-intercept is still 10. And 10 is still the product of them because negative 9 times negative 1 gets me 9. All right, so that's pretty much it for today. So what we've seen so far is, let me get back to Word. That's going away. We are not ready for more. It's a terrible problem. It's actually a decent problem, but it's too much work. So we've seen that different forms tell us different interesting information. So we have standard form that tells us something, and we have factored form that tells us something else. So in standard form, we can see that the y-intercept is just that last term. It's at 0, 7. But it doesn't really help us find the x-intercepts. And this graph actually has no x-intercepts, and you'll definitely learn about that later in the year if we get there. But it turns out this graph doesn't have a very nice factored form. Anyway, side note. So when a function is expressed in factored form, we can see the x-intercepts. So we see f of x is x minus 4 times x minus 1. And that's all on the next page. So I guess I'll just put it on the next page for you. But we can see in f, my x-intercepts are 1 and 4 from my graph, and they're 4 and 1 from my equation. And in g of x down below, x plus 2 times x plus 6, we see the x-intercepts are negative 2, 0 and negative 6, 0. And the 2 and the 6 are also in the equation, and they're being added to x. So really, if we're flipping the signs, we're really, in factored form, is really saying that you subtract the intercepts. So it's really x minus 0 times the x minus the 0. And it's not the number 0, it's where 0 refers to the x-intercepts. So it's really subtracting the 0. So if there's anything you're taking away from this, that's a great thing to take away. X minus the 0 and x minus the 0. That's really what's going on in both of these functions. And the y-intercept is, of course, the number that's being added in standard form. So again, we're practicing this. We will have a mid-unit review this week at some point, probably Friday. It's where I would put in like a class test or something, but you're not really going to have a test because we're distant. So I'll have something more summative in nature. Then for Friday's class, it'll probably be a 2-day assignment thing. I'll have plenty of time to do it. So yeah, look forward to that. And make sure if you have questions that are pressing, you are emailing me or scheduling time to meet on Win Wednesday. I did not have a very busy Win Wednesday, so I'm hoping that this week, hopefully more of you are reaching out if you need help on Wednesday. All right, enjoy your form.